Hey, how you doing? My name's Elton and welcome to the show. So it's a new month, so it's a new theme, and this month we're talking all about service mesh. So service mesh is this kind of architectural pattern that really takes advantage of the fact that you're running your applications in containers. So you've got this layer of consistency about how they all work, and you're running containers in a platform like Kubernetes, which is easy to automate, it's easy to plug things together and do discovery and all sorts of things like that. So the service mesh pattern itself doesn't actually depend on having containers or Kubernetes, but it's much easier to layer on top of your architecture if you're running in that kind of environment. And obviously, that's what this show is all about because it's a container show. So for this month, we're going to have a different service mesh every week, so you can compare the kind of the major offerings. They all have a very similar feature set, but they all work in slightly different ways. We'll dig into them each week, and we'll learn about kind of what they offer, so you can compare them and decide which one you want to go and progress with. But there's quite a lot of new concepts in around that whole service mesh space. So rather than throw you into a bunch of stuff with Istio, we're going to start this week with a bunch of slides. So it's one of those kind of, depending on how you think of these things, it's one of those boring episodes this week where we just have some slides with some diagrams because I'm going to explain all the concepts and how all these things fit together. Because that's true of all the service meshes that we'll be looking at, the things that I'll be walking through in terms of what they can do and how they do it. And that will really set the ground for next week when we start looking at a real service mesh. So usually, if you're new to the show, hi, my name's Elton. I'm a Docker captain, Microsoft Azure MVP. I'm a consultant and trainer. I help people learn about and use containers. The format of this show is we have a different theme every month, and then each episode is digging into one aspect of that theme. So usually it's all demos. So I do my talking head bit. I switch over to my other camera, and then it's demos for 40 minutes, showing you how this stuff works in practice. And all those demos are in a GitHub repo. You can follow along for yourself. This week's slightly different because we really need to have the groundwork to understand how all these pieces fit together. So the demos that we'll have for the rest of the month make sense. So if you're not into slides, then now's the time to switch off. Thank you for staying so long. Although maybe wait until the advert so you can see the other stuff that I do. But if you're interested in learning about the architecture of this stuff, then today's episode is for you. And then the rest of the episodes this week, this month, we'll be digging into some of those actual implementations that we're going to use. Okay, so I'm going to switch over to here to show my slides. You can see all the things I'm talking about. While I do that and my green screen and all the other stuff, I'm going to roll my really short advert to tell you about the books I write and the courses that I do online. And I will see you in about 20 seconds over there. You're watching Elton's Container Show with your host, that's me, Elton Stoneman. These shows are live, unscripted, and unrehearsed, so if you like my style but you prefer something a little more polished, then you should check out my courses on Pluralsight. Pluralsight's an online training platform, and I've got tons of video courses on there that you're bound to find useful. And if you prefer to learn by reading, then you'll be interested in my books, Learn Docker in a Month of Lunches and Learn Kubernetes in a Month of Lunches, which are both published by Manning. And if you just want to see what I'm up to, then you can check out my blog. And now, back to the show. Okay, so I'm over here this week. How do you like that? Usually I'm in the other corner, but for my slide format, you're going to have me in the top left, key points underneath me, and then the actual diagram on the page that we're looking at. So the first thing to understand about service mesh is it's all about taking the network communication between the parts of your system. So we're talking about a distributed application where different components run in different containers or in some sort of different host, and they need to talk over the network. And rather than having them communicate directly, like we can see in this diagram here, so I've got like a website at the top there that's consuming some service from an API, that's consuming some data from a database. So they're gonna make network connections, they're gonna make their calls, they're gonna get their responses, and they're gonna go on their way. What you do with a service mesh is that you kind of take control of that communication and you elevate that into a separate thing that you can control independently of your application components. And the way you do that is you have, if I get the right clicker here, is you have a piece that injects itself into the network stack. Sounds complicated, isn't wonderfully complicated. You have a network proxy that is actually taking control of the communication going out and coming into your components. And that's what the service mesh is. The service mesh owns all of those proxies that are positioned into your components, and the configuration of how these things talk to each other and what should happen, what the behavior of the communication should be, that's all controlled centrally in the service mesh. And there are a bunch of features which are common across all of the technologies in this space. We're going to just kind of walk through those before we move on to looking at how this stuff actually gets accomplished. So the three main areas are like service discovery. How do I find the service that I want to consume? How do I send my traffic into that thing that's running on a different container, on a different machine, or even on a different cluster? traffic management. So what's happening with the communication between A and B? Is it being encrypted? Are there retries? All that sort of stuff. We'll dig into some of the patterns that you can do. And then observability. So if you saw last week's episode, which was ECS v4, it was all about getting observability for your applications without changing a bunch of code by using a sidecar and letting that sidecar be an adapter between your application container and the Kubernetes environment that it's running in so that it can do things like logging and add metrics and add observability. And that's what we're going to be building on here. The reason I finished with that last week to talk about sidecars, and now we're moving on to service mesh, is that in the Kubernetes world, the service mesh takes advantage of that sidecar pattern, and that network proxy is going to be a sidecar. So we will see some of the benefits of observability that we had to kind of manually put in the previous month when we looked at things like Jaeger, and you will see that with the service mesh, you can get some of that automatically. Okay, and so digging into some of those a bit more. So service discovery. One of the goals of the service mesh is that you can make your network communication in your code really simple. So you're not worrying about infrastructure level details like making sure that your network call succeeds and then retrying it if it fails. A timeout to make sure that if you can't connect to the server, how long do you wait, and then what should you do if that timeout period expires? And simple things like the address. So in this case, inside your code, my website might have a really basic address to get to the REST API, just HTTP//API. And then from the API to the database, it's just a container name, or it's just a service name in the Kubernetes world and the port that it needs to communicate with. And you keep the actual network code inside your components super simple, and you layer on all the other stuff that you need at the service mesh level. So with the service discovery part, you can let the service mesh work out the actual address that you want to go to. So my service A is talking to service B. My website's consuming from my API, just using the API domain name. But in my service mesh configuration, I can provide the real domain name that it should be using, which might be, another component in another namespace or whatever. And then you can split the traffic. So because you own the address, you can, when my website thinks it's talking to my API on this domain, you can intercept that and send it somewhere else. And that enables you to do all sorts of interesting deployment patterns, because then suddenly you control the flow of the traffic between all of your application. And as you're doing upgrades, you can kind of manually decide where you want your traffic to go without having to edit your application configuration or any of your deployments. You can control all that stuff centrally at the service mesh level. So classic example there is your blue-green deployment. So maybe I've got a big change to my API. It's still kind of behind the scenes. It's still working in the same way. It's talking to the same database, but I want to do a bulk swap over from my current deployment, my blue deployment, to my green deployment. I don't want to change my API, my website configuration. I don't want to change the address that it's talking to. I don't want to change any of the way that it communicates. I can do all that in my service mesh layer. So by changing the configuration of the addressing in my service mesh, then I point all of my traffic from my website to the new version of my API. A couple of really, really clear advantages for that. So firstly, it's a central configuration. If I've got lots of things that are consuming that API, I don't need to go and edit them all. I can just, I don't need to go and make changes to my application config for this website and this API and this other service that are all consuming that central API that I want to update. I don't need to change the configuration, and I've got a consolidated way of doing it, which is just one set of config. So all those components that consume the API might be running different code bases. So they've got different HTTP libraries with different ways to configure them. I don't have to worry about those low level details. I don't change my applications, which means I don't need to do like a hot reload of my configuration or replace my containers to change environment variables. Everything stays running. I'm just switching the traffic at the network level to the new deployment. And the second big benefit, as well as the consolidation, is that my old deployment, my blue deployment, is still running. So in the Kubernetes terms, I've got a bunch of pods and a service that's running my green API deployment, but the pods and the service that are running my blue API deployment, they're still there. They're not consuming too much CPU resources or memory, hopefully, because they're not processing any traffic, but they are there and they're hot and they're live and they're ready to go. So if I have a problem with my green API deployment, I can just reverse the change to my service mesh config, point everything back to the blue API, and it's still up and running. So I don't get any kind of slowing down when I switch from A to B, because everything's up and running and still alive. So I'm not waiting for a new deployment to be scaling up and creating new pods and new containers. And the other thing that you can do, of course, with this sort of deployment pattern, because the service mesh owns the decision of where the traffic actually goes to, you can do a more complicated traffic split. So if you've got a big change here, so in this diagram here, I've got my new API, which is a kind of grey-blue color, is using a completely different backend database. So maybe I don't want to do a big bang deployment for that. I want to do a very gradual canary deployment. And again, you can do that at the service mesh level by configuring the amount of traffic that goes to each endpoint. So currently, when I do my new deployment, I might do a shadow release where I don't send any traffic to my backend API. I'll make sure it's all up and running, and then gradually, with a switch in my service mesh configuration, I can send a small amount of traffic to that new API, validate that it's all working as well as I expect it to, and that's my canary deployment. I can send, maybe 2% of traffic to the new API, and that's when my monitoring and my observability metrics come in, and make sure the new API is working the way that I expect, and then gradually ramp it up. So I'll do another deployment of my service mesh to switch it from being, what did I say, 20%, 20% to 30 to 40 to 50, to eventually I'm sending everything to my new API. No traffic's going to my old API, but it's still there, so it's still able to roll back and send traffic there if I need to. And again, you're not changing any code in that. You're not changing any configuration of your applications. You're not changing the deployments of your pods or your containers. You're just changing the spec of your communication, your service mesh setup that tells the website proxy where to really send the traffic to. Okay, and then the traffic management part. So it's slightly, you can categorize these however you like, but the features kind of fall into different areas. So when you're looking at the actual traffic that's going from the client, the thing that's consuming, to the server that's providing the service, you get all sorts of other benefits. So like load balancing, like retries, and like fault injection. So load balancing is an interesting one because you get load balancing anyway in your container platform, or you should if you're using a proper container platform. So with Kubernetes, you'll get that at the service level. So you've got, a cluster IP address, which represents the service as a whole. And then if you've got multiple pods behind that, then you'll get load balancing between those pods. But that's kind of fairly basic server side load balancing. So it's just gonna round robin effectively, either using a virtual IP address or with DNS round robining, just to make sure that there's a spread of traffic to all of those backend pods. What you can do with the service mesh is, because it owns the traffic from the client to the server, it can monitor that traffic, and it knows about the ultimate endpoint. So it doesn't necessarily just send traffic to the Kubernetes service. It knows about the endpoint for each pod, and it can track the availability of each individual pod. So that if client A always has a problem with pod B, so I've got my 1, 2, 3 pods that are in my backend service. If one of them isn't responding correctly to a particular client, then the load balancing in the service mesh can be aware of that and take care of it. So it will direct traffic somewhere else. So it's a lot more fine grained. It's monitoring the performance at a client to server level, and it can configure load balancing to make sure we avoid endpoints that are potentially giving us problems. And it will take them out of the load balancing, give them time to repair themselves, hopefully, and then gradually kind of bring them back in. And then you've got things like retries. So if there's a network communication failure, then you always get this in a distributed application. There are going to be transient failures to do with the network, or something is temporarily gone down, or you're in the middle of a release or something like that. So the service that you're consuming isn't available just for 10 milliseconds or whatever. It just happens to be the very moment that you're trying to make that call. Now, typically, you would have to put a whole bunch of code inside your application to deal with that, and there are a whole bunch of libraries in every platform that will let you do that. So if you're a .NET person like me, there's Poly, which is a retry library that lets you wrap up your code and say, no matter what's happening inside this block of code, if there's a problem, do it again, do it 3 times, wait 10 seconds in between, gradually add more time, all that sort of stuff. But because it's at a code level, all of your application components need that stuff in there. You need that block of code for all of your network calls, or you put up some sort of factory around it. And then you need the configuration that says, we're gonna, for this particular endpoint, actually the number of retries should only be 1, and then we should only wait 10 seconds. But for this one, it could be 10. So it just becomes a big sprawl of configuration and different libraries for different components, putting in that, which is effectively an infrastructure level concern. But with the service mesh, you forget about that stuff. So in your client code, I make a call to the service, and that's it. I don't have to write code to do any retries, because if the network call fails, the service mesh can retry it for me, and it does it kind of at the network level. So it says, I couldn't reach. Here's the network packet that I needed to send. Here's the request that I needed to make. The endpoint didn't exist when I tried to do it, so I can be pretty sure that transaction didn't go anywhere because the server wasn't there to listen. So I'm just going to repeat the whole thing. I'll just send that packet or send that request in again, and hopefully the server will be up this time. And if it's not, I'll wait 10 seconds and try again. And that's all transparent to the application. So the application thinks it's sat there waiting for a network request, whereas actually in the communication channel, the service mesh is retrying it until it gets a success, and then it sends the response back to the client. The client thinks it was one request, one response, but actually the service mesh is taking care of all that kind of retry stuff. And again, that's, you can apply that across the board, across all of the components in your application without having a bunch of different libraries and a bunch of different configuration that you need to work with in different ways. And the flip side of that is sometimes you want to inject default deliberately. So if you're doing some chaos engineering in production, if you're brave enough for that, or if you're just doing some fault testing in a non-production environment, you can have your communication between your components. You can have faults randomly injected by the service layer to say things like add a 30-second timeout and make sure that your client behaves in the way that you expect it to if the call times out after 30 seconds, or do throw a 500 response and make sure that your client is able to carry on doing what it should do even in the event of a service failing. And that happens at the actual network level, so you're not trying to fake up a response at the TCP level or the HTTP level. You actually get an HTTP 500 without having to put all that kind of chaosy code in your server. The server's just sat there working happily, but the service mesh is saying this particular call, we're going to throw in a fault here and we're going to return with a 500 without ever touching the server. Client gets a genuine HTTP 500 response, and you can make sure that your app degrades gracefully or carries on in whatever way you expect it to when some of the components are unavailable. And that all happens at the service mesh level. It's all configured in that same kind of chunk of configuration that says, here's the actual address you should be going to. Here's how you deal with the load balancing. Here's how you deal with retries. And actually, in this scenario, maybe even for this group of users, we're going to inject these faults. Okay, and then let's have a look here. So the next thing we can do with traffic management are these things that will be coming up here now. With traffic management is because the network communication, if you own both sides of that, so in this case my website and my API, they both have proxies. So my service mesh can control the traffic going out from each component, and it controls the traffic coming into each component. If you have that setup, which you will for a kind of a distributed application where everything is running in containers in the same container platform, then you can apply your security at the network level, again at the service mesh level. So you don't have to worry about inside your application code dealing with certificates, which is just a nightmare to make sure that my communication between the web component and the backend API needs to be encrypted. So I need to have a certificate for the server. If you want mutual TLS, which means that the client presents its own certificate, so the server can validate who that is. And then I've got encryption from end to end. I've got certificates both sides. That is not terribly difficult to accomplish, but it's managing the certificates that's really hard, because then you need to make sure that your code can deal with picking up a certificate when your web server starts, when your application server starts. It needs to know where to get the certificate from. You need to make sure you secure the supply chain from your source code to your application to make sure there isn't a certificate in your source code repo, there isn't a certificate inside your Docker image, because those things could be hijacked. You need a way of injecting that certificate at runtime in different environments, so different certs for staging and your production environment and your development environment. So it gets kind of ugly, and then you get self-signed certificates, and then you need to accept them and all that sort of stuff. So it's difficult to do to get that security in depth to make sure you're encrypting between all of your components, which is why people don't do it. But with the service mesh, it's actually pretty easy because the service mesh owns the certificate management. So when you register each of your components with the mesh, it sets up the proxy. So it sets up all the proxy rules that you want to apply. And also for each component, it will generate a certificate. It stores the certificates. It rotates them when they expire. It deals with all that stuff. And it gives a certificate for each component. So you get that mutual TLS. So when my website wants to make a call to my API, inside the code and inside the configuration, it's just an HTTP call. There's no encryption there. There's no HTTPS. There's no certificates. But at the network level, because of my configuration in my service mesh, when the network call gets initiated, the service mesh applies the client certificate. And then on the back end, when the API, which again is only listening on an HTTP endpoint, it's not listening on a secure endpoint, it presents its own certificate at the service mesh level, and the communication is encrypted without either of those components needing to be configured and set up with your HTTPS certificate. So that's really super cool. And once you've got that mutual TLS, then you can do your authentication and your authorization to say, for this particular backend service, only these consumers should be allowed to call into it. and they should only be allowed to make these particular sets of HTTP verbs. So, my website can make a GET request to this API, and it can make a POST request to that API, but no other components can. So it's a much finer grained level of control than you get with network policy in Kubernetes, which lets you restrict the flow of traffic at a very broad level, and saying that you can't send any traffic from A to B. With your service mesh, you can go down to a much lower level and say this particular operation is allowed for this particular client. And depending on the service mesh, that authentication isn't just necessarily service to service, but it could even be end user. So if the end user of your application presents a JWT, an authentication token, that can flow across all of your network communication for your application, and you can have your backend services saying, I will only respond to this API call if the end user presents me with a JWT and I know which claims they have, and I can verify they're in a particular department or whatever. So you can do end user authentication and end user authorization, which is more of an edge case, but the normal case is to have that at service to service level and own all that stuff inside your deployment as part of your service mesh configuration, without a whole bunch, again, without having some kind of authorization subsystem that you need to keep in sync. That can all be part of your application spec, which is presented with in terms of your service mesh configuration. Okay, and then the last one, which is the big feature, is observability. And some people only use a service mesh to get the observability. They don't care about the deployment patterns because they can do that in a different way. They don't care about the security because, again, they've got some other approach for that. They just want to see what's going on inside all of their communication, and you get that with the service mesh too. So you can have your backend services. And again, if you saw all the episodes from last month, that was the ECS-V episodes. I talked about Prometheus, which is the metric collection. I talked about Jaeger, which is distributed tracing. You can set up your service mesh to deal with a lot of that stuff for you. So as the proxy level is intercepting all the client requests and intercepting all the requests of a server, it can send the information that you need to Jaeger. So it can build up those tracing reports that you need. So you don't need to have your client library inside your application that knows about Jaeger that sends that information on. And at the network level, the communication level, you can record metrics that come from your proxy, so we can detail the amount of time each network call took. So that, you can look at your distributed tracing to see the overall time span for a particular transaction, and then flip over to Grafana and see the detail of the network calls that are going from A to B. So really detailed, and for all the proxies. It doesn't matter what's happening, what level of communication, whether it's HTTP or just plain TCP traffic. You get more information if it's something that the service mesh understands, typically HTTP traffic and gRPC. Those are the sorts of requests and responses that the service mesh understands, and it can get some metadata from that and make more sense of the metrics that it's storing. But it can record all sorts of information in there, and low-level logs to the level of recording individual network calls that happen and sending it off to your Elk stack, which again we covered last month. So all that stuff gives you the traffic visualization, which is something that is really big. When we look at the demos later on in the month, there's a really good product called Kiali, which will give you this network visualization in real time of all the components in your application, the traffic that's going through them. If you've got a Canary deployment, it'll show you the real time percentage that's going to your new component versus your old component. You can verify everything's working as it should, and you get this really nice dynamic view of what's going on in your application, which is really hard to get without something that owns the network, because you don't know the pieces that fit together. We get the distributed tracing. If you remember from last month's episode, we did that in a kind of custom way by running a proxy as a sidecar and setting up that proxy to send the traffic to Jaeger. The advantage of the service mesh is it does all that stuff for you, but you still need to have those HTTP headers. So I talked about that last week. Most of these features you get without having to change code. Because the network level, you can do an awful lot of stuff without having special code in your applications. But for the distributed tracing, you need to be able to, or the service mesh and Jaeger need to be able to piece together all the parts of a larger transaction. So you need that kind of that coordination to say that this call is correlated to that call, is correlated to that call. So those HTTP headers we looked at to record effectively a transaction ID and flow it all through the chain. You need to have that in your code, but you don't need to have the Jaeger client library. You don't need to be kind of dealing at that level because the service mesh will do all that for you. And then metrics and logging, so you can go down to a really low level. And the point of this is, if you are in a production like Kubernetes environment or a container platform of some sort, and you already have these problems solved for the other parts of your application. So you've got your centralized logging, you've got your centralized monitoring and your dashboards in Grafana, you've got your distributed tracing for some other components, then those are subsystems that your service mesh can just plug straight into. So when you bring a new application onto that environment, you don't need to have the custom code to take advantage of the back ends that you've already got running. Okay, so how does this stuff work? Well, it's all to do with a network proxy, which is not a hugely difficult concept. You've probably worked with proxies before. They work at different levels. So there's an ordinary proxy that you'll have in your corporate network. So when you make a call to the internet, you think you're going directly to http eltons.show, but actually it's going through your corporate network, which has a bunch of rules to say, are you allowed to go and visit eltons.show and all that sort of stuff. So that proxy is handling the network communication for you transparently, so you don't know what's happening. And maybe if you work for a particular type of corporation, it's recording how much time you spend in different places, all that sort of stuff. But it just looks to you like you're going directly out to the network. The kind of proxy that we have here is going the other way around. So it's kind of it's sitting inside, and it's kind of managing both ends of the traffic. So my proxy will do that for each component that's making an external call out of the web, out of the network layer, but also any incoming request. It can apply behaviors to both sides of the conversation. And this is why we tend to talk about service mesh architectures in the scope of Kubernetes, because it's really easy to apply that proxy to all of your components just by running a sidecar. So we talked about sidecars, and we used Envoy, which is a popular proxy. Not all the service meshes use Envoy, but a lot of them do. It's a super high performance network proxy that you can configure to do all sorts of interesting stuff. But the complexity, the difficulty with having your proxy in there and having your Envoy configuration is that there's a whole bunch of stuff that you have to do. So it runs as a sidecar. That's a fairly standard pattern. That's not too hard to do. It's the network proxy, so it will intercept any calls that your component is making, that your application container is making. Remember, the pod in Kubernetes, that is the environment that all the containers in that pod share, and they share the same network space. So the proxy can own that without the application container knowing anything about it, and it applies all those rules that you configure at the service mesh level. All the load balancing stuff, all the retry stuff, they get applied in the proxy for each component from the central configuration that's happening at the service mesh level. And you can extend this stuff too. So some of the service meshes let you take, and this is fairly new, but let you take a WebAssembly component and plug that into your proxy to add whatever behavior you want to add to all of your network calls without having to dig down into writing an Envoy extension or a whole bunch of custom code running in pods in elsewhere in your platform. You can do it with a WebAssembly module that just gets sent out to your proxies. So pretty powerful stuff. The disadvantage of this, and we saw this last episode, is that it is quite complex to configure. So this is a snippet from the pod spec of that I showed of in the last demo of last week, ECS-V4, where I was manually applying this pattern. So I've got inside here, I've got my application container, which is my service one image, and I've got a proxy that's running in the same pod. That's my service one proxy. And there's a bit of configuration there to say what's going on and where the traffic's running. Not super complicated, but if you're owning this yourself, you need to make sure you're applying that to every component that you want the pattern to apply to. And then the other side, and this is just a tiny snippet, this is the Envoy configuration that says what should actually happen when the network calls are being made. So when my service container, my application container in the pod is trying to make a network connection or receiving a network connection, it's actually going to be the Envoy container that deals with it. And this configuration is going to tell Envoy what to do in every single scenario. And I talked about this last week and said, like, this is super complex. You would never normally build this stuff out because it lends itself to being automated by a bunch of very, very simple rules, much more expressive rules that you just say, here I'm going from A to B, and this is the traffic split, and this is the retry policy, and then convert that into Envoy for you, and that's what your service mesh is going to do. So you don't have to worry about that complex configuration yourself. The sidecar setup can all be taken care of for you by your service mesh, so it can register the network proxy container into all of your application pods, and it does the Envoy configuration for you. And if you didn't see last week's episode and you don't know what I'm talking about and you do want to get that grounding, go to eltons.show/ECSV4 and you will see exactly what I was talking about. The final demo from last week is this kind of clunky demo that you would never normally do in production of owning the Envoy configuration yourself and injecting your own sidecars. But I wanted to show you lay the kind of groundwork for how a service mesh actually works and why you wouldn't do it yourself and you would use a real service mesh. Okay, so check that out if you didn't see that, and you'll get some of the background. But what you get with the service mesh is that it takes care of that for you, because the service mesh is a separate thing. It's this control plane that runs inside your cluster. And so, your Istio components or your Linkerd components, they're a separate bunch of pods running in their own namespace, and they're going to watch out for your applications for you and take care of all that configuration. So they're going to inject that proxy container into all of your application pods, and they will provide all the configuration that you need for Envoy, mapping it from the fairly simple, I wouldn't say actually all that simple, mapping it from the fairly simple expressive rules that you've got at the service mesh level into that much more complicated, much more verbose Envoy configuration. So it will take care of the sidecar for you. It will take care of the network proxy, and it does this automatic injection. So all of the major kind of service meshes do this for you now. So you can set it up to say that in this particular namespace, every pod that runs in there should have a network proxy applied, and it will just inject all that. It will just inject Envoy into every single pod. Now, Envoy runs in a container. It's super lightweight, so it doesn't add much overhead. It does add a little bit of overhead. So running a service mesh will add some compute resource and some memory requirements to your overall deployment. But we're talking kind of small percentages on top of whatever you're currently running. So the advantages you get from having that centralized configuration and all the behaviors you can apply typically outweigh the cost, hopefully. Okay, and so these are the three we're going to be talking about. So this is the kind of overview. Most of the service meshes have the same or similar feature set. The expression of how they apply those things is slightly different, but these are the main ones. So Linkerd, Istio, and Open Service Mesh. So Linkerd was the first. It started off as being effectively more to do with service discovery, and it was first launched in 2016, which is a long time ago in the container world. It's now at version 2.9. It's a CNCF project. So it has all the benefits of being a CNCF project, like Kubernetes and Prometheus. So it has, it has a recognized steering group and all that sort of stuff, and everything is public, and you can kind of get involved with it. Istio is the one that really took off. So when service meshes started to get really big, it was when Istio started making a ton of noise. So it was first released in 2017, but come kind of 2018, if you were at KubeCon that year, there was an awful lot of Istio stuff going on. So it really made a big noise, even though Linkerd had kind of predated it. Istio was the real big one. It came out of Google and IBM. It's now at version 1.8. It's pretty stable. Lots of people use it. It uses Envoy internally, so it doesn't do the proxy code itself. It relies on Envoy, which is kind of super hardened, super stable. So it devolves all the network configuration to Envoy, but it sets it up for you. And the new one is called Open Service Mesh. So you'll see that the Istio is not part of the CNCF. And if you go and have a read around, there's a few kind of interesting developments around there. Istio was intended to be a CNCF project, but late in the day, Google decided not to donate it to the CNCF and for it to become part of a separate foundation. There's a really nice blog post from one of the guys at IBM who worked on that initially, saying, "Why have you done this?" And it's probably not an issue for you. So if you're really into, when we look at Istio, you'll see it's super powerful. It's a really nice product to use. Complicated, but then if you know Kubernetes, then you're already dealing with complicated systems. But the fact that it's not part of the CNCF, and there's this kind of it doesn't have the benefits of a project like Kubernetes. So Kubernetes, there are so many players involved in it. No one company could really dictate direction. So it's part of the CNCF, the steering group, all that stuff. It's all really about making sure that it's a community project that works well for all the people who are involved. It's not, no one vendor could take it in a particular direction. And a lot of people are slightly concerned with Istio that it doesn't have that. And if Google wanted to add features or to do something that meant Istio works better on Google Cloud than anybody else's cloud, it doesn't have the backing of something like the CNCF to try and kind of stop that happening. So that may or may not be an issue for you. When we come to the Istio episode, you'll see it's a super good product. And the fact that it's not part of the CNCF is something you just need to kind of bear in mind. And then the reason that the Open Service Mesh came out, it was kind of in a reaction to that. So Istio was getting really popular, but like everything that gets super popular, people worry about having a dependency on a particular technology. Just like with Docker in the early days, people were really worried about the Docker image format and the Docker runtime format. So Docker, the company, spun that out into a generic spec that other people could adopt. And the service mesh interface, SMI, did the same thing for Istio. And hey Lee, how you doing, man? So fellow Captain Lee is on the call, and he is telling me about Meshery. Yes, you should absolutely check that out. So I'll hop onto a browser in a second and show you that. So Lee super knows his stuff. He wrote the book about Istio. It's a great book, and you will learn about all that stuff from his book. So the service mesh interface was really an attempt to have a generic spec for what a service mesh could do. So you don't have to take the Istio specific configuration. You can have that layer of abstraction on top to say, these are what the rules look like. Give it to whatever service mesh I'm running, and they'll run in the same way. Early days for that stuff, but Linkerd supports SMI, Open Service Mesh supports SMI. So, that might be something that gives you that kind of level of protection if you're concerned about being locked into one particular product. Okay, and I've talked primarily about Kubernetes. So all these things work with Kubernetes, and they all work in a similar kind of way. So there's either a custom command line and or a Kubernetes operator to deploy the control plane. So the control plane is going to sit there. It's going to watch for any new things that get created. It does that injection of the proxy and the configuration and all that stuff. And there's typically a bunch of custom resource definitions. So if you're not super familiar with Kubernetes, as well as all the standard resources like pods and services, Kubernetes has these extension points, so you can define your own resources, and you can your code that's running inside Kubernetes can watch for those resources being created and do things with it. So super simple way to explain that. And that's what these service meshes do. So you define your rules in a custom resource. When you deploy that to Kubernetes, the back end, the control plane, sees those new resources and does whatever it needs to do. And that's why this is really nice stuff, because your service mesh rules that describe how the traffic is going to be managed as it flows through your application components, you're going to apply them with kubectl apply, the same way that you deploy your application. So it can all be scripted, it can all be automated, and you don't have to learn a new set of deployment tools other than the CLI that the service mesh gives you itself. And then the way they do that stuff is with mutating webhooks typically. So when a pod gets created, you can have this webhook registered in Kubernetes that can change the specification of the pod, and that's how the service mesh will inject the proxy for you. So when my pod gets created, the first thing it does is it hits the Kubernetes database, and then Kubernetes will fire off all of those webhooks that are registered and say, here's a new pod waiting to be created. And then if I'm an Istio webhook or a Linkerd webhook, I will inject another container spec into the pod, and that's going to be my network proxy, and that will take care of dealing with all the communication. So it's all automated, all really fits really nicely with Kubernetes. That's why this world kind of emerged from Kubernetes and is such a good fit, because you have those hooks and you can automate all that stuff. But it's not exclusively for that. So Istio can work with virtual machines. So with each virtual machine, you deploy an agent, which is the proxy, and you use the same sort of levels of configuration. You get similar sorts of behavioral benefits. And the ones that I've talked about here are not exclusive, not the full set. So the obvious one that's missing is console from HashiCorp, and that also works at Kubernetes level and at virtual machine level using agents. Okay, so that's what we're going to be looking at. So I'm going to start in that order. So next week, Linkerd, then Istio, then Open Service Mesh. If you can't wait, then this is the Pluralsight course that I did. It's a 5-star course, very, very well respected. If you go to eldons.show/Istio, you can watch that. I dig into all the details of what you can do. And then obviously you can go and buy Lee's book, and you can get into the next level of detail about that stuff. If you don't have Pluralsight is a monthly subscription, but you can get a free trial and you can watch that episode. If you haven't seen, I've got my new Udemy course, which is also a 5-star course. That's specifically for people who are getting into containers from a .NET background, which was my background for a long time. So elders.show/Udemy will take you there. And then the last link I've got for you is, every now and then people ask me questions during the show which are nothing to do with today's topic, which is fine. But what happens is then I try and, like last week, I had to say, like, ping me an email or send me a Twitter request. So I've got a new thing here on my 6i/ECS is the GitHub repo for all of the show stuff. If you go to eldons.show/AMA, you can ask me anything you want me to ask. So if you've got a question that comes up during the show and I don't answer it because I miss it, or it's completely off topic and I want to get on with my demos, go to eldons.show/AMA, put in a GitHub issue about what you want to ask me, and I'll pick it up that way. Okay, and so next week is ECS-M2 service mesh with Linkerd and Kubernetes. Before I do that, seeing as Lee is on the call, I will open up Firefox and show you the stuff you can get from Lee. It's Lee Calco, who's a super nice guy and a Docker captain like me. If you go to meshery.io, this is an Uber service mesh. So it understands about all the other service meshes. It helps you deploy them, helps you evaluate them. Leaves on a ton of stuff to really bring all the options under this one banner. So if you want to explore that stuff, do it with Meshery. And if you go to, is it Istio in Action? Is that your book, Lee? I'm going to feel bad if it isn't that. Here we go. Is this Lee's book? No, it's not Istio in Action, is it? It's the other one, isn't it? It's Istio. It's from O'Reilly. So I'm a Manning author, so I always think about the Manning books. O'Reilly. Is that an O'Reilly one? Lee, if you're still on the call, tell me what your book's called, because I can't remember. I need an Istio in there, don't I? I need another O. Anyway, if we're up and running, it's the up and running series. So go to Istio up and running. It's a really good book from Lee. Who was a Docker captain, and Zach, who was one of the original Istio maintainers. So those guys kind of really know their stuff. So that's a good place to go. So, and if you're interested in what this is going to evolve into, then stay tuned for the rest of the series this month. So we're going to Linkerd next week, then Istio, and then Open Service Mesh, and we'll see where that takes us. So no questions so far today. That's good. If you do have a question, remember eltons.show/AMA, and I will pick it up. There is no service level agreement there, so I'll pick it up when I've got time, but I will try and help you if I can. Thanks for tuning in. My name's Elton, and I hope to see you again.